Hi everybody and welcome to your Thursday's maths. So we're going to carry on with our fraction learning. So yesterday we were doing fractions, adding and subtracting fractions with the same denominator, okay? But today we're going to be taking that next step. So as your fluency today, let me just share my screen with you. We're going to rewind all the way back to our learning from a few weeks ago to do some equivalent fractions. Okay, so let's just pause because my equivalent fraction is in my word selector red. So what is an equivalent fraction? You need to have a look back in your book, have a look at, but hopefully it's been in a few of your box set questions, box set previews, so hopefully that you are aware of what an equivalent fraction actually is now. So just make yourself aware. So I'm hoping that you are saying that an equivalent fraction has different numerator and a different denominator, which shows the same value. Okay, it shows the same amount of that whole, even though it's cut into different parts and you have a different amount of them, they show the exact same amount of that same whole. Okay, so what I would simply like you to do is to rewind your knowledge of finding equivalent fractions, and I'd like you to match the fractions on this side with their equivalent fractions here. Now, what I would really like you to do is to prove how you know. So in your books, I would like to see this. So question mark might be, don't know which one, is equal to this one. But I would like you to prove it with that little diagram there. Okay, so remember you put something there and something there that proves your equivalent fraction. Okay, once you've done that, then you can come on back and see how we've got on. Brilliant. So hopefully you have had a little go at those. So let's have a little look then. So here I've got 6/12. I'm going to start with my 6/12. And I'm going to have a look what has happened to 6/12. And I'm going to try and see. Right, I know. I'm going to rewind some of my knowledge. I know the relationship between 6 and 12 is that 6 is half of 12. So remember, whenever your numerator is half the amount of your denominator, we know straight away that that is also equivalent to 1/2. Let me just get my prove it pen. And I'm going to prove it to you. So what's happened there? I've got 6 times less parts. So if that is correct, whatever happens to the top also happens to the bottom. So 12 divided by 6 is 2. So that one is equivalent to 1/2. So well done to you if you got that one right. Now let's think about this one then. So 3/4. Let's see. I know it can't be this one because there's no relationship between 4 and 18 because 18 isn't in my 4 times table. It's not a multiple of 4. So let's have a look at this one. Is 30. So 6 is a multiple of 3. So I can see a relationship there. But 40, 4 and 30, there's not a relationship. So I think it's going to be this one here. So let's do this. Let's get my prove it pen. Let's think about what has happened. So what's happened there to get from 9 to 3? I've divided that by 3 because 3 times 3 is 9. So hopefully, yes, 12 divided by 3 is 4. Brilliant. Right, this one here then. Let's have a look. Let me get rid of my pen. Let's go for 1/5. So I know straight away which one of those is more likely to be an equivalent fraction because my 5 times table, those multiples of 5, always end in a 5 or a 0. And this one is 18. So there's no relationship there. So I think it's going to be this one. Let's get my pen. Let's change the colour. Let's go for blue. So what has happened there? I have got 6 times as many parts. So that's got 6 times bigger. So 5 times by 6, 5, 10, 15, 20, 25, 30. There we go. So I've got 6 times as many parts, but they are still equivalent because they still show me the same amount. Now, hopefully, let's move this one over here. We should be able to see a pattern. Now, I know straight away that 12 and 2 have got a relationship. They're both in my 2 times table. And 3 and 18 are both in my 3 times table. So I know that there's some sort of relationship there. But let's have a look to see if it's equivalent. Because remember, whatever happens to the top also has to happen to the bottom. So this one here, how have I got from 2 to 12? Well, I've got 2 lots of 6, so that's going to get 6 times bigger. So then hopefully 3, 6, 9, 12, 15, 18. Yeah, it's got 6 times bigger. So hopefully you have got those in your books and you've just rewound that process of finding those equivalent fractions. A really, really good skill for finding those keywords, those common denominators, remember, because when we're trying to compare them or when you're trying to add, it's better to have those same denominators so that they're easier. Let's get started with today's learning. Fantastic. So what we're going to be doing today then, we're going to be adding and subtracting fractions with different denominators. So now I'm hoping you're seeing why we just did our equivalent fractions as our fluency this morning, because we're going to be using that skill quite a lot because we are going to be adding and subtracting with different denominators. This is going to be a little bit of old learning because, like I said, we're going to be using our knowledge of equivalent fractions. And why? So that we can find the total amounts and solve a range of different problems. Different problems. Because as we say, life is not always as easy that everything has always got the same denominators. So you need to have that skill and know how to tackle them if they've got different denominators. So let's have a little look at this then. I've put my little help it up here with our pattern. Our method of using and finding equivalent fractions. So here, how much pizza is left in total? Okay, so this first question here, we are going to be looking at the pizza. So what fraction of pizza is left there? What fraction of pizza is left there? Okay, and how much pizza is left in total? That key word there, in total, is giving you a big clue about what you need to do. Okay. And then once you've had a go at that, I want you to then think about what you're going to have to do before you are able to add or subtract those fractions, and what knowledge are you going to have to use. Okay, so there's some questions that you might want to ask yourself as you're answering that question. Once you've had a go at that, there is question B, which is there are 2/5 of a litre of juice. Danny drank 3/10 of a litre. How much juice is left in the jug? So there is my keyword for that question. So I'm just going to get a little underline for you there. What are you going to have to do there? Okay. And as always, are there any drawings or diagrams that you could use to help you to find out if you are correct, or to use to help you to solve this problem? Okay. There's a little clue of a diagram you might want to use there that's going to help you. And what we've just done in our fluency. So question A and question B. Once you've done those, come on back to see how you got on. Okay, so hopefully you've had a go at that now. So let's have a look at this first question then. So what am I going to have to do to solve this problem? So how much pizza is left in total? So the first thing I'm going to do is I'm going to look at what pizza I've got, what pizza I'm working with. So you can see here, there's the outline of those 2 slices that have gone, and there's 1 slice left. So I can see I've got 1 slice of that pizza that was originally cut into 3 pieces. I'm using my knowledge of the numerator and the denominator there. So there were 3 pieces that I was cut that hole into, and I have 1 of them left. Okay. The other pizza, let's see how many slices that one was cut into. 1, 2, 3, 4, 5, 6. So I know my numerator is 6. And again, I've got 1 of those left. Okay. Now I'm going to look at my question. So how much pizza is left in total? So that keyword, key part there, in total. If I am finding the total of something, what am I going to be doing with these 2 fractions? I'm, of course, going to have to add them. So hopefully that is a number sentence that you got to start with, okay? But now I'm going to think about my explain it. So can I just simply add these 2 fractions together? Okay, remember what I always say, can you add apples and bananas together? No, okay, because they're not the same. So obviously here I'm working with thirds, and here I'm working with 6. It's really tricky to add those together. So what do I need to do so that I'm able to add them together? I need to find that common denominator. So that denominator that they can both be in, so that they are easily added together, so I can add apples and apples, okay? So here I can see straight away that I've got a relationship between 3. and 6. So this is your decision on whether you are turning them both into thirds or whether you are turning them both into 6. Now, if I wanted to turn them into thirds, I know that this is half of this, so I would have to divide by 2. But because I've got a 1 on the top, can I divide that by 2? No, because it's going to give me an answer that's less than 1, okay? So what I need to do is I know that I'm going to have to now convert this third into 6. Okay, so I'm going to use my knowledge. What has happened to my parts? Well, 3, I've got 2 times as many parts. So I've times it by 2 to get my denominator. Okay, and remember when you're doing equivalent fractions, just like that model that I've given you a clue there, whatever you do to the bottom, you also do to the top. If you need to know, you need the same amount still shaded in, even though you've chopped them into different parts. So I need to do the same with my 1 times by 2, which is going to give me 2 6. So 1/3 is the equivalent fraction of 2 6. But now I've got 6, I can now easily add my other 6 to it, and it's just like we did yesterday. My parts still stay the same, they do not change sides, so my denominator is still 6, because it doesn't change how many equal parts make my whole, but the amount of them that I have is going to change. So here I've got 2, there I've got 1. How many do I have now? I've got 3 6. Now, if you were using this knowledge on Monday, you will also notice that I could simplify this fraction, because that is equivalent to something else. My top number, my numerator is 3, my denominator is 6. I know that 3 is half of 6. So I know that that is also equivalent to 1/2. So if you wanted to simplify that fraction, because here, look, if I split this into 6, if I've got 3 of them, that is equivalent to 1/2. So I can simplify that. I can make that as the parts as big as possible, which means my number is as small as possible. Okay, well done to you if you got that correct. Okay, so now let's focus on this second one then, okay? So we've got the information, we've already got the fraction in the question. So there is 2/5 of juice, a litre of juice. So I've got 2/5 of a litre, don't forget your measurements. Danny drinks 3/10 of a litre. How much is left? Now, as soon as I use the language is left, what does that make you think of? What am I going to be doing? I'm going to be taking away, okay? Because this is how much I've started with. This is how much Daniel's drank. So this is going to tell me what is left, okay? But again, I've got that same problem as I had before. My denominators are different. So it's going to be really, really tricky for me to do anything with those fractions because they have not got the same denominator. So I'm going to find a common denominator. Now, I can see straight away that 5 and 10 have got a relationship. So I'm going to use that knowledge to help me. Same again, I can see here that my knowledge of 5 and 10 is that it's got 2 times as many, or I'm going to divide them by 2. To get from tenths to fifths, I'm going to have to divide by 2, but look at my numerator. Is that going to be easy for me to divide by 2? No, no, no. So the best thing I'm going to do is to turn my fifths into tenths. So again, I'm going to turn that into tenths. What have I done to get from fifths to tenths? I've got 2 times as many parts, so I've times that by 2. Whatever you do to the bottom, you do to the top. 2 times by 2 is 4. So 2/5 is equal to 4/10. Now you can use your fraction rule with this as well, but this is probably a quicker and an easier method for you to use if you are confident with it. If you're not, you can still use your fraction rules. Okay, so 2/5 is equivalent to 4/10. Now I've got 4/10 of a litre. I can now take away 3/10 of a litre, and that will nice and easily give me an answer. It's still going to be in tenths of a litre because remember the parts don't change unless you're using equivalent. But when I'm taking away, if I've got the same one, that does not change. We're still working in tenths. And now I simply need to do 4/10, take away 3/10. 4, take away 3 is going to leave me with 1 of those tenths left. So the answer to question 2 is 1/10 of a litre. Well done to you if you got that correct. Now, you might have used this sort of diagram, but you could have also used your pictorial representation. So here I might have had 2/5, and this one I'm working in tenths. Oh, wasn't a very good drawing, was it? Five, yeah. Right, so this is not as accurate as I would like it, but it's just to show you. Okay, so you might have drawn your 2/5 and your 1, 2, 3 tenths, and then you could have simply changed your fifths into tenths, which then you would have seen that this is equivalent to 4/10. Okay, so you could have used your drawings to help you, and then you could have easily used this to take away 3 of those tenths, and you would have had 1/10 left. Okay, so as long as you've used whatever method you are more confident with to get you this answer. Let's get on with another activity then to practice this new skill. Okay, so use it challenges then. So you can see here, I've got 3 little problems for you to have a go at, and then there's an extra little challenge here. Okay, so what I would like you to do is have a go at this one, then this one, and then this one here before you then challenge yourself to convince me. So at the start of the party, there were 2 cakes. Here is what is left. How much of the cake is left in total? So here they've already done the equivalent fractions and the number sentences for you. You're just working out what those missing numbers are here. So here you can see they've done equivalent fractions from quarters to 8, so that they're both in the same denominator, which then is translated here, and then this is their answer, and this is the answer there. Okay, this one here, use the fraction strip to work out 2/3, add 1/9. So here you can see they're converting, finding the equivalent fraction for 2/3 into 9ths. So what is that as an equivalent fraction? Draw those arrows on if you need to, or use your pictorial representations here. And then here, so they've written the original number sentence that they're doing, which is equal to this one and this one. So this is the one that stays the same. This one is being converted. No, found the equivalent fraction. And then here is your answer. B, use your own diagrams to show these calculations. Okay, so this is simply what we've just been doing. They've given you 3 number sentences that they want you to have a go at finding the equivalent fractions. So then you can complete the sum. Okay, there's some little clues here that you might want to do that. So first I will find a common denominator, then I will use my knowledge of equivalent fractions. Okay, this one here, I will cross out the parts in my own diagram as I subtract, as this will help me to keep track. So again, whatever method you are more confident with, you can use that one. Once you've had a go at those, there's a little convince me here. So I've had a little go at trying to solve this problem. Can you convince me what is wrong with this answer? Okay, where have I made that mistake? Once you've had a go at those, can you come on back and see how you got on? Okay, so let's have a little look then. So hopefully you've had a little go at this now. So at the start of the party, there were 2 whole cakes, okay? So they've had a good time, really. They've eaten quite a lot of cake there. There would definitely not be that much left if that was my party. So how much cake is left in total? So they've noticed here that 1 cake is in 8ths, and 1 cake is in quarters. So they've decided that they are going to find the equivalent fraction in 8ths. So 1/4 is equal to how many 8ths? So what has happened there 4 to get to 8? I've got 2 times as many parts. So each of those parts have been cut in half. And so I still need 2 times as many of those pieces to get the same amount of cake. So I've got my 2/8 now. So my first number sentence was 1/4 plus 3/8. But now the 3/8 can stay as 8ths, but I've converted that quarter into 2/8 now. So now I've got the same denominator, which is 8ths, which is good for me, so I can add them together. Now I've got 2 pieces and 3 pieces. How many do I have altogether? I've got 5 pieces. So how much is left? 5/8 of the cake. So well done to you if you got that one right. So this one here, we're working with thirds and ninths. So they've seen that there is a relationship between thirds and ninths, so they're going to use that as equivalent fraction. Now this one, rather than doing my mental methods, I'm going to use this pictorial representation here, because you can see the one underneath is ninths and this one is thirds. So I'm going to chop my thirds. It's hard to do straight lines on here, but hopefully if you've done this at home, you could use a ruler. You've got your 9 parts now. So here you can see that 2/3, the blue parts, is equivalent to how many ninths? 1, 2, 3, 4, 5, and 6 ninths. So you can see how I use the pictorial representation there to help me. So instead of now doing 2/3 and 1/9, I've now converted and the equivalent fraction of 2/3 in ninths, which was 6 ninths. I'm adding that 1/9, that doesn't have to change because that's already in ninths. And now I can simply add them together. So I've got 6 and I've got one more, which now means I have got 7 ninths. So I can prove that. 1, 2, 3, 4, 5, 6, 7. There we go. Wonderful. Now this one here, you have got to do your own working out here because there's no physical representations, there's nothing, so you can do your own diagrams to draw this. So here I'm working with 8 and here I'm working with a half. Now we know straight away that a half in 8 is going to be equivalent to the numerator being half of the denominator. So if I want to change that to 8, what is that number that's going to be equivalent? Because it shows a half, it's going to be 4. So now I can do 7 eighths, take away 4 eighths. So let me just write that. 7 eighths, take away 4 eighths is going to give me what answer? 7, take away 4 is going to give me 3 eighths left over. There we go. Okay, so that one is 3 eighths. This one here, I'm now working with 15ths and fifths. Again, I can see that relationship there straight away because they are both in the same times tables. So I'm going to convert my 1/5, find the equivalent fraction in 15ths. So what has happened to get from 5 to 15? 5, 10, 15. So that's 3 lots. So I've times that by 3. So whatever you do to the bottom, you do to the top. So 1 times by 3 is 3 15ths. So now I've got 4 15ths. I'm adding those 3 15ths because they are the equivalent fraction to 1/5, which is going to give me 4 15ths, add 3 15ths, which is 7 15ths. 7 15ths is your answer there. Okay. And finally, so you can see this one, once you've got an answer, there's also another equals. So we can go back to that question that we did at the start, where once you've got your answer, there may be a simplified fraction. There's a way that you can make that fraction even more simple, those smaller numbers, remember those larger parts. So let's see what answer we get. So this one here, again, I can't divide by 2 because my top number is odd. So I'm going to make my 6s, my 6 into 12s. So what has happened there? I've got twice as many parts. So I'm going to times that by 2. So whatever you do to the bottom, you do to the top, which is going to give me 10 12, because I've done 5 times by 2. So 10 twelfths, take away 7, so 12, 11, 10, 9, 8, 7, 6, 5. So I've taken 7 away, it's left me with 5 twelfths. Oh, what am I doing? No, that is not right. Let me look at my question again. 10 take away 7. So not 12, I don't know where I got 12 from. 10 take away 7. So 10, 9, 8, 7, 6, 5, 4, 3 left. So it's actually 3 twelfths. Okay, 3 twelfths. Now I can see a relationship here because 3 and 12 are both in what times table? They're both in your 3 times table. So how many lots of 3? So I'm going to divide that by 3 because that will get me to 1. Remember, the smaller you can make your numerator, the simpler that fraction is going to be. So I personally always try and see if I can get it down to 1. And if it works for the bottom and the top, then you've got your simplified equivalent fraction. So that one I divided by 3 because that's going to get me one of those pieces. And 12 divided by 3 is 4. So actually that is equivalent to 1/4. Well done to you if you got that correct. Fantastic. Okay. And then finally, then this convinced me. So well done to you if you got onto this. So you can see what I've done here is that I've added my numerators and I've got 7 and I found the equivalent fraction into tenths. But what did I forget to do? I found the equivalent fraction, but actually I changed, I knew that I had to change it to tenths, but what did I not change? The numerator. So my parts got 2 times bigger, but I kept it as 2 tenths because then I've done 5 tenths, I had 2 tenths. I forgot to change that numerator into the equivalent fraction. So actually it should have been 4 tenths. So actually that answer should have been 9 tenths. So well done to you if you spotted my mistake. Okay, so let me just get rid of all that drawing. It's very distracting. Brilliant. So we're going to go into Power Maths books today then. So remember, we are adding those amounts with different denominators. So you're going to be finding those common denominators and using your knowledge of equivalent fractions. Whatever you do to the bottom, you do to the top. Okay. There's also pictorial representations that are going to help you. So if you need to use them, use them. So question 1 is all about just what we've just been practicing. So finding the equivalent fraction and then writing what the new number sentence looks like to get yourself, an answer. Question 2, they've drawn the diagrams for you. So you can see they've started with the parts and then they've put the dotted lines for the new parts. So this first one is fifths and tenths. So the stronger lines show you what the fifths and then the dotted lines show you the tenths. Okay, so you can use that, but it's the same setup. They find the equivalent fraction. There's the original number sentence. This is what my new number sentence looks like because I've changed them both into tenths and my answer will be in tenths. Okay, this one here, you will see that you can make your answer in the simplest form. So this is where, remember, we're trying to get that numerator and those denominators as small as we can possibly make them using our knowledge of equivalent fractions and those relationships between numbers. And then this one here, using the diagram to work out 7/20, take away 1/5. Okay, so using this diagram here to help you to solve this. So the same number sentence setup. This is the original sentence. This is what I'm going to do now, and this is my answer. Okay, this one here, they've given you the answer, but which numerator is missing that's going to give you that answer. Be careful because they have got different denominators. So you might have to do a bit of extra working out here. Once you've had to go at those, there's just some simple number sentences there that you can do your own working out in that box. So there's no steps that you need to complete. It's just whatever you feel necessary to get me that answer. And then you have got your challenge here as always. Once you've done all of that, remember you don't have to get onto the challenge as long as you get on and practice your skills. If you need to just stop after question 1 and do a little bit more practice, then that is absolutely fine. But here they want you to explain the mistake in this calculation. What have they done wrong here? Okay, what have they done wrong here? So they've done 1/4, add 5/8, and they think that their answer is 6/12. Give you a clue, look at those denominators. Something is not possible there. Wonderful. We hope you are absolutely smashing and loving your fraction learning. I know some of the children in school have been saying that how interested they're finding fractions, which is great to hear. Remember, send all of your work onto Portfolio so we can see how you're getting on. And we will see you all again soon. One more online maths lesson until you're back in school with us, and we'll see you all soon. We're all very excited. Goodbye.